Hey, Miss Sparks.
Hey, Braden, how are you?
I'm good. How are you?
I'm good. How are you? Pretty good.
That's good.
It's sorry it took me so long. The the Algebra 1 had lots of questions today. That doesn't
Oh,
always happen, but of course when I'm trying to get to the other one, that's typically when it does. Do
can we also
you
go
want to
can we also go over the other sheet?
tell me say that again, please? You've kind of faded out at the end.
Yeah, the speaker's not working well. Let me put my earbud.
The speaker's not working well. Let me put my earbuds. Okay.
Can we do the other worksheet?
Can we do the other worksheet? This one?
Yes, ma'am.
Yes, ma'am. Absolutely. We can do whatever you want.
Okay, yeah, I got to number
You're the
10,
boss. Okay, yeah, I got to number 10.
and 10 and 11 were tricking me up.
And 10 and 11 were tricking me up. Okay, so 10 and 11, but were you okay on 8 and 9? I did those in class, didn't I, or did I?
I don't remember. That you might have done it Monday, but I wasn't there.
You might have done it Monday, but I wasn't there. Oh, no. No, this would have been Wednesday. But do you this is a bonus tomorrow? Being able to put it in vertex form after completing the square?
Yeah, I didn't do those because I didn't understand that one either.
I didn't understand that one either. Okay, so you complete the square first. So let's go over those.
Okay.
So you complete the square first. So we've got x squared. Let me erase some of this stuff so I have plenty of room to write. X squared minus 16. And then I'm going to go ahead and make my space and move my 56 over here.
Okay.
So I subtracted 56 from both sides. Does that make sense to you?
Why do we subtract 56 from both sides?
Why do we subtract 56 from both sides? Because we're completing the square. In order to complete the square, you have to get the constant to the right side.
Okay.
That's different than the other things that you do. But when completing the square, you have to get the constant to the right side because on the left side, we're trying to create a perfect square trinomial. So that's where we half it, square it, add it.
Yes, ma'am.
So half of negative 16 is
Negative. Negative 8.
negative 8. And then you're going to add 64 to both sides because whatever you do to one side of an equation, you have to do to the other.
Okay.
And so now we've created on the left side right here, we've created a perfect square trinomial, which factors down to when we remember when we half it, squared it, added it, that half was negative 8. And so 64 minus 56 is 8. Yes? Is that right?
Yes, ma'am.
Did I do is my math right? Please help me. Oh my gosh, my dog makes me absolutely crazy.
Does he want to treat Miss Sparks?
This is the one that likes to talk to me. I'm sorry?
You got to give him a treat.
I know. Just always whining. Always whining. Anyway, so I did do my math right. So this is where I am now at this point, right?
Yep.
And so to get it in vertex form, all I'm going to do is move over this 8 back to the other side. My work is so messy.
It's all good.
It sparks.
It's all good. Let's see. And then you're going to just have it equal to 0, right?
And then you're going to
just have it equal to 0, right?
Yes, sir.
Okay.
Or I could even set it equal to y. It doesn't matter. But this looks very much like what we were doing back at parent functions. So this tells me what the vertex is, which would be 8, because I take out the opposite of what's inside there, and then negative 8. Because that's the x coordinate and that's the y coordinate. So you complete the square to get it to the vertex form.
Okay.
Okay.
Yes,
And
ma'am.
then you can identify what the vertex is. So we'll do number 9 because that is the bonus on the test. The other bonus on the test for coming to math lab, these are the things that you get to know, Braden.
Yes, ma'am.
The other bonus on the test is the question, what are the other 3 names for the solution of a quadratic function? And that would be x-intercepts, zeros, and roots. So there's your bonus.
Wait, x-intercepts, zeros, and roots?
Yes, sir.
And those are your...
The question is, what are the other names for the solutions? Because you know how we're solving all these quadratic functions? And it says solve by completing the square, or solve using the quadratic formula, or solve by finding square roots. When you're solving, you're always getting usually 2 answers. And those 2 answers are where that parabola will cross the x-axis, thereby called x-intercepts, but they're also called zeros and roots.
Okay, yes, ma'am.
So that's the other bonus. Does that make sense?
Yes, ma'am.
Okay, cool. All right, so once again, number 9, same.
Because
What,
I'm
love?
talking to you like
are
a
fading
second.
in and out on me.
Yeah, I'm talking like a second earlier, and then it comes in a second later. I can hear myself talking every time.
You've got feedback.
I can hear myself talking every time.
Oh, I hate that. That happens to me a lot too. To pull out your headphones and put them back in and see if that helps.
Okay.
See if it clears it up. Did it?
Let me see. Is it working now?
Did it help?
No, it didn't help.
Ugh.
Well,
Hey, Miss Spark.
Okay. Well.
Hey, Miss Spark.
Yes.
Hey, this is Simone.
Hey, Simone. How are you? Are you joining me and Braden?
Yes, I am.
Well, welcome. We are working on number 9 on one of the worksheets from yesterday currently, but any questions you have, I can help you with that. What I told Braden just a second ago was number 8 and 9. Basically, you're completing the square to put it in vertex form to identify the vertex. And these number 8 and 9, there's 2 bonus questions on the test tomorrow, and these are the bonus questions.
Oh, wow.
This is one of the bonus questions. Oh, wow. So, I mean, it's not these exact numbers, but the concept itself. So what you would do is you will take, like, I'm going to do number 9. I just did number 8, but I can go back to that one. But you take 8x squared minus 8x plus 11 equals y, but you would just, you would set it equal to 0. And then you're going to move the 11 over. And then you've got x squared minus 8x. And you're going to leave yourself some space to complete that square. Because what you want to do is turn the left-hand side into a perfect trinomial by halving, squaring, add it. Half it, square it, add it. So half of negative 8 is negative 4.
And then 16.
And negative 4 squared
16.
is 16. So I'll add 16 here. I'll add 16 there. Because whatever I do to one side of the equation, I have to do to the other.
Mm-hmm.
And when we halved it, that gave us our factored form of the perfect square trinomial. So half of negative 8 was negative 4. So you have x minus 4 squared equals, and then negative 11 plus 16 is 5. So in order to get it in vertex form, all I'm going to do is move this 5 back over to the left-hand side. And so now when I write it just like this, it is in vertex form. And my vertex would be 4, negative 5. Because whatever is in the parentheses, it's the opposite of that. And whatever's outside the parentheses, you take it as is. So the vertex would be 4, negative 5. So once you've completed the square and you put it into this format right here, you're able to identify the vertex. So number 10. On this one, it says the area of the playground shown is 96 square yards. Complete the square to find the value of x. So what you're going to want to do on that, and I'm probably going to try, you're going to want to go ahead and FOIL, because to find the area, x plus 15 times x plus 5 equals 96. Because the area is the length times the width. Yes?
Yes.
So we've got x
Yes.
squared plus 15x plus 5x. And then 15 times 5 is, I didn't leave myself very much room here. $75. And then I have x squared plus 20x plus 75 equals 96. I'm going to subtract 75 from both sides. And that leaves me x squared plus 20x. And then over here, I have, what do I have? 21. So half it, square it, add it. Half of 20 is 10. 10 squared is 100. So I'm going to add 100 to both sides. I didn't leave myself very much room over here. But that's going to be 121. And now I'm going to take the square root of both sides. And that leaves me x plus 10 on this side. And the square root of 121 is 11, plus or minus 11. And then I'm going to subtract 10 from both sides to get my x all by itself. And 11 minus 10 is 1. And negative 11 minus 10 is negative 21. But when I'm dealing with a measurement, I know that I can't have a negative measurement, correct? Because you can't have a negative 21 yards. So I know the only answer that is a possible logical answer is x plus 1. So the x would equal 1 here.
Do we have to put like a positive?
Did you all follow that?
Do we have to put like a positive?
On the 11?
On the one.
Right here? Is that what you're asking, Simone?
On the one.
On the one down here?
Mm-hmm.
On the answer? No, because the one of your answers was x equals 1. You don't have to put the positive because you're basically looking at positive 11 minus 10. So that's 1. And then the other answer is negative 11 minus 10, which would be x equals negative 21. But that's not a logical answer because you can't have like a negative 21 feet when you're measuring something. You can only have a positive. So you could just write x equals 1, which is fine.
Okay. Thank you. Okay. Thank you.
Uh-huh. Did that make sense?
Yeah, it does.
Did y'all follow that all the way through? And figure out where my setup was? Like where you have to, the area of a rectangle is length times width. And that's where I got that. And then I had to FOIL.
Yes, that makes sense.
Brayden, are you still with me? I know that it echoes when you say stuff, so you're probably limiting what you're saying.
Yeah,
because I know how irritating that is. I hate
also doing it for other people too.
Oh, is there other people on here?
Yeah,
I have lots with me.
Well, it's Simone and Rachel.
It's not you and Simone anymore.
Well, it's Simone and Rachel.
And Rachel?
Yeah.
Rachel. Oh, okay. Hey, Rachel.
Hi.
I can't really tell who's here
That's
when
okay.
I'm over here.
When you have a chance, I do have a couple of questions.
Okay.
It's echoing.
It's echoing. Is it echoing for you too?
It is.
Yuck.
It's okay.
Yeah, like I
Ugh,
can hear everybody what they're saying in it. It says quiet.
Wonder what causes that. I get feedback really, really bad sometimes. I'm going to turn my volume down. Does that help a little with the feedback? Did that help anything?
I don't know.
No.
Whenever you have a chance, can you do number 15, please?
15?
Yes.
Okay, I sure can. And then I can go back and do 12, 13, 14. Does anybody care if I jump around? Does anyone object to that?
Nope, I'm good.
Okay. So we're finding the discriminant and give the number and types of solutions. So the discriminant is that part that's just under the radical of the quadratic formula. So that part just by itself is b squared minus 4ac. So the first thing that I'm going to do, or that I have to do always, is identify a, which is 1, b, which is -8, and c, which is 10. My writing is atrocious on this screen. So I've got b squared, which is 8 squared minus 4 times 1 times 10. That is a 10, I promise. So I've got 64 minus 40. Which is 24. So that tells me that this would be the square root of 24, which is going to be an irrational thing, but there's two real solutions.
Okay, so I have a question.
But it's an irrational number.
So
Yes.
whenever you have, for the square root of 24, do you need to take out a thing in front of the radical sign? Do you understand what I'm
No.
Okay.
No, not for this. That's a really good question, but no, not for this.
And then
Just to know that it would be, to me,
Go ahead. I'm sorry, it's echoing again.
Go ahead. I'm trying not. I was going to say just to get it to here to know that it's two real solutions is absolutely fine. You don't have to go beyond that.
Okay, so for number 17,
Because you're talking about the fact that. Yes, ma'am.
So for number 17, I got down to negative 80. So
Yep.
do I need to take that out of that? Can you
So
just
it's two. Just write this: two imaginary solutions.
I don't even need to put what it was.
You can put negative 80. You don't even have to put it in the radical.
Okay, that was my question. Thank you.
You can just write negative 80. Uh-huh. You just give me whatever the value is and then tell me what that value tells you. Like it's going to be two imaginary solutions. It's going to be two real solutions. Or if it happens to be 0, then you would tell me there's one real solution. Were there any of them that were 0? Yes, there was one, right? Or no?
Yeah, there was.
Okay.
Are you going to post the answers to these questions?
I am going to post the answers to the questions, but what I don't like is the answer key to the book. It actually, like for number 15, it says this 24, like it gave the answer is 24, and then it's semicolon and it says 2 irrational, like that. And that's not what I'm looking for, because that means absolutely nothing to me. Okay. I mean, I understand that the square root of 24 is irrational, and I'm sure that you guys too, but what I'm looking for is that it's two real solutions. You know what I'm saying? Because even though it's a irrational number, it's still a real solution, and it's still going to cross the x-axis.
Okay.
I want two real, and then number 16, it actually says 0 like this and one irrational solution. But I don't want to see that. I really want to see real. And I don't have any way to correct it because it actually comes from the textbook. So I guess what I'll try to do is, actually, I know what I'll do. I'll pull it into a word processing document and fix it, and then I'll post it.
And then are you going to post the answers to the other one too?
Yes, ma'am.
Okay. Because I understand how to do it. I just don't know how far.
Just so that
I understand how to do it. I just don't know how far. Do you want me to like?
I got you.
Yeah.
So this is what I'm looking for here.
Okay.
So if you gave me that, I'd be good. You know, like if you showed me your work, like if you actually worked out the b squared minus 4ac and showed me how you got 24, 0, and negative 80. Now I'm echoing.
So, like, how do you tell if it's an imaginary or real?
Good question. If I had the square root of 24, you know that that's a real number. It's an irrational number because if I take that out, it technically is the square. It's 2 times root 6. If I break it down, but it is a real solution because there is an answer to that. Okay, because you have to remember this part right here is typically under the radical. So if this is true, like if it's really and truly a real number, like so if it's 100, then that's going to be
It's
10.
all just about
like
that
the answer
negative.
would be
If there's a
10, and there's
negative,
one
then
real
it's
solution.
Then it's not real. If it's a negative, it's imaginary.
Right. It would have 2 imaginary solutions.
Okay.
Does that make sense?
Yes, ma'am.
Hey, Miss Sparks, I have a question.
Okay.
So, if on the test it said like to simplify, would that just mean to write in standard form?
It's echoing so bad. Yes, to simplify. So what on these,
Mm-hmm.
remember back when we were doing these, way back when?
Yes.
This one's pretty easy actually, because here you're just gonna do 3. What's the square root of 10? I mean 100 is 10. So that's gonna be this. But this actually goes to, whoops. Does that make sense?
Yes, it does.
That's how you would simplify that one.
Can you break that down for me again?
Yes.
Thank you.
Let me start over and explain each step. So I'm going to simplify the top by doing 4 times 2, because I'm kind of looking for perfect squares. And then I'm going to simplify the bottom by taking 3 times the square root of 100, which is 10.
I'm so confused.
And the square root of 4 is 2.
Like, why wouldn't you multiply the top and the bottom by the square root of 100?
Because if I can actually take the square root of 100 without having to do the other, I mean, I would want it because 100 is a perfect square. I don't really need to do that step.
I don't understand how to do
So
it.
what they're kind of asking you to do. Okay, so if it wasn't a perfect square, I would have to multiply the top and bottom by the radical. But since it is a perfect square, I do.
Yeah.
So they're, basically that's one of those things where you're going to kind of have to, like, let's say if it was the square root of 2 over the square root of 5. Obviously, there is no square root of 5, so I would have to multiply the top and the bottom by the square root of 5, which that's going to give me the square root of 10. Horrible writing.
Okay, so can we go through number 4?
Absolutely. Okay, so here we would do exactly what you thought we would do on number 3, but every now and then, these worksheets, when they're coming up, they're trying to make sure that you are, that you know what a perfect square is and when to simplify and how to simplify in all the various methods of simplifying things and looking for those perfect squares. I'm going to erase this. Did everybody get that before I erased it? Hopefully.
Yes, I did.
Who needed it?
Yes, I did.
Okay, good. All right. Number 4, to simplify, we're going to take the conjugate. And the conjugate is 4 plus the square root of 5 over 4 plus the square root of 5. So we're going to distribute our 3 to both of those. 3 times 4 is 12. And 3 times root 5 is 3 times root 5. All over. And this is like the conjugate is much like multiplying by the difference of squares, So I would square the 4, 16, and then I take negative square root of 5 plus root 5 minus 5. And then that gives me 12 plus 3 times root 5 all over 11.
And that's the final
And
answer.
that's my final answer.
Okay.
Yes, ma'am.
Okay, so I did that for number 5 and number 6. I'm not
Yes, ma'am.
simplify the answer from there.
Okay. I can work them out.
Okay.
I'll just skip down to
Wait, can
6
you
if
do
you
that
would
up
like
there,
for
Miss?
me to.
Okay.
Oh, so sorry.
No, it's good.
I'm sorry. I'm sorry.
No, it's good.
Okay. Did you get that part that I erased?
No, I kind of did it in a different way, but that's all right. I'll figure it out.
Okay. Okay. Sorry. I can just rewrite it because it's not all that was me writing down the conjugate of each side. So that's not really that big of a deal. That's what that part was. I'm multiplying this.
Could you
Right
also
there.
do that
Okay.
for number 3?
So the conjugate for number.
also do that for number 3?
No, that's what we were just talking about the fact that when you're looking at that square root of 100, 100 is a perfect square.
Oh, okay.
So no, you would just you would take it out.
Okay.
So you kind of have to look at each problem and approach it like you have to look at it and know, okay, well, I can't have a radical in the denominator, but is what's in the denominator, is it perhaps a perfect square? So if it was a 9, a 64, a 16, 100, a 121, a 144, 400, 225, any of those, you kind of, what you might want to do if you don't know all of your perfect squares, up over 100, you might want to actually, just go ahead and work it out on your calculator and see if in fact it is a perfect square before you move forward in that case.
Yes, ma'am.
So let's do let's do number 6. So the conjugate for number 6 is 2 minus 8i. I'm going to kind of get into my other problem, unfortunately. Can you still see that clearly, guys? Is that okay?
Yeah, that's fine.
That's the conjugate.
Yeah, that's fine.
And so I'm going to FOIL the top and the bottom technically, but the bottom's going to end up being prettier than the top. 9 times 2 is 18. And then 9 times negative 8i is negative 72i. And I times 2 is 2i. And a positive I times a negative 8i is negative 8i squared. All over. And then this, once again, is much like the difference of two squares. So that middle term is going to cancel out. So it leaves me with 2 times 2 is 4. And 8i times a negative 8i is going to be negative 64i squared. Combining like terms and actually breaking down the I squareds, that's going to give me 18i minus 70i, because 72i plus 2i is 70i. And then negative 8, this actually is negative 8 times negative 1. So that's going to be a positive 8 all over 4. And this turns into negative 64 times a negative I. So that's going to be, or a negative 1, I apologize. So plus 64. So once again, combining like terms, I've got 18 plus 8. That's 26 minus 70i for the top. And then 4 plus 64 is 68. On the bottom. And each one of these terms, the 26, the negative 70, and the 68, are all divisible by 2. So I can actually reduce each one of those. This would become 13. This would become 35. And this would become 34. So the final answer is 13 minus 35i all over 34. Ever so pretty. Is that what you got, Rachel?
It is. Thank you.
Oh, no problem. Good job. That's a lot of work. Did everybody follow along with that? I tried not to skip any steps, so.
Yeah, that makes sense.
Okay, good.
So on like number 7 through 10.
Yes,
like,
ma'am.
You don't have to work all of them out for me, but like the ones that looks like you have to foil them. Would you put it in standard form?
Perfect. You're a genius. That's exactly what you would do. That's it exactly. Awesome. So the constant being in the lead, followed by the imaginary number.
And then like how would you work out number 7? Like that type of equation.
Number 7, you want to use great caution because you're combining terms and you've got, so what you're looking for, and I'm just going to go ahead and underline some of these. I'm going to take my real and underline those with pink. So this is my real number. And remember, in algebra, every sign has a number and every number has a sign. So you've got, now that's my imaginary. And here's another imaginary. So I have by the looks of it, I have a -4 with a -5. So that's going to give me -9. And then I have a +3i with a -8i. So that's going to give me a -5i. And that should be in standard form.
Oh, is that
and
all?
That would be my final answer. -9 minus 5i. I'm sorry?
Is that all?
Yes. On number 7 and 8. Mm-hmm.
Wow. Okay.
Yeah. Now, number 8, you have to be really cautious because look at this negative sign here. That has to be distributed to both things inside the parentheses, but you just have to be very, very careful. That's what I said. Number 7 and 8 are, the math is relatively simple as long as you're watching your signs and your distribution properties. Because on that one, you've got 7i plus 3. I would actually break this down and go ahead and take that negative and distribute it before I started combining my terms. Because that negative would make that 7 a negative, but it would also make that 4i a negative. Okay? So now I've got 7i minus 4i, which is going to give me 3i, but I have 3 minus 7, which is going to be -4, and then this is a positive. So I've got -4 plus 3i. Does that make sense?
Yes, that does.
No.
Okay. Yep. And that's all there is to number 7 and 8.
Wait, could you go over number 7?
Am I good to erase some of the work off of 6?
Yeah, you can erase all the work off of 6.
Okay.
Can you wait? I'm kind of confused on 7 and 8 though.
Okay. Let me, let's break it down again. And what we're doing there, let me erase this part so I can kind of re-talk back through it a little bit. Well, all we're doing is combining like terms. And we have an I, which are imaginary number, and we've got some real numbers, real constants. So what we want to do is take our real number. Oh, I made that imaginary before, so I don't want to do that. That'll be confusing. We've got our real number, which is -4. And in this particular case, got a -5. Those are our only two real numbers. And there's no distribution really going on at all where it's, I mean, there is a negative being distributed to that 8i, but it's not like it was in number 8. So you've got a -4 and a -5, and you're just combining them. Does that make sense, Brayden?
Where did the -5i come from?
Okay, and the -5i comes from +3i and a -8i. So when I take a +3i and subtract an 8i from it, I get -5i. So my final answer is -9 minus 5i.
Yes, man, that makes sense now.
Okay.
So let me try to do 7 on my own.
And then number 8. Oh! Everything shut down on my laptop. Oh. Technology is a blessing and a curse.
Ms. Sparks?
Yes.
Are you going to upload this to
I'm trying to bring everything back up. But my my Google stuff, just everything shut down. I can't even believe that that I'm still connected to you guys.
I was going to say, are you going to upload all this to YouTube?
Oh, the whole math lab?
Yeah.
I sure can.
Because I don't really have a lot of time.
I can, and then I'm also posting answers too.
That'll be a lot easier for my schedule.
Okay.
Miss Sparks.
Yes.
The discriminant is just everything under the square root. So it's squared minus 4ac. Correct?
Yes, ma'am.
Okay, that's all I needed to know. Thank you.
Uh-huh. Okay. I think we're going to get it back. Oh my, that was something else. Okay. This is where we left off. Well, Braden, that gave you plenty of time to do 7 and 8. While Miss Sparks regained everything back up there.
Well,
How'd you do?
I understand it now, so that's good.
Well, praise the Lord.
Yeah.
That's awesome. All right. Do you want me to do 9 and 10, or do you feel good about foiling?
No, those are easy.
Okay. And just the key thing, the foiling's not that big of a deal. It's just the key thing on those is to remember that I squared is that -1. And so instead of having, 3 terms like we often do when foiling regular binomials, we get a trinomial. You're always going to have a 2 answer, and it needs to be
Can you do number 1
in
and 2?
standard form with the real number first, followed by the second. Followed by the imaginary, I mean. I'm hearing myself echo, so I can't think.
Can you do numbers 1 and 2?
Yeah, and also, let me see. Isn't that awful, Momo? Number 9 actually comes down to just one value. And that's the answer. So I may want to do that. Which one did you ask me to do? 1 and 2?
Yes, ma'am.
Okay, so solve by taking square roots. So I'm going to subtract 10 from both sides. So I get a -28. Square, take the square root of both sides, and I've got a equals. And this actually is the same as -1 times 7 times 4. So -1 is I, and the square root of 4 is 2. And then you put the 7 in the root. So you have plus or minus 2i root 7. Did that make sense?
Yes, ma'am. Hold on. I'm in the middle of doing that.
Okay.
What is that noise?
I don't know. That's awful.
Okay, those are easy.
Okay, so you feel pretty good about those?
Yes, ma'am. And then, can we do... I think I get everything else, so I think I'm good, actually.
You feel good about completing the square?
Yes, ma'am.
From our, okay, and you just plugging in the quadratic formula, just be real careful, because that's the place where you can run into some squirrely things just because there's so many moving parts.
Yeah. Thank you, Miss Sparks. I hope you have a great rest of your day.
Oh, I hope you do too. And please email me if you have any other questions, okay?
Yes, ma'am, I will.
All right, have a blessed afternoon.
You too. You too.